Hey, you! Get into my space weather show. After all, welcome to the Daily Space Weather Show. It's only the world's most comprehensive daily space weather and solar imagery. No big deal. And of course, with the emphasis on private space flight, well, it's not going anywhere. We've got pretty calm conditions, X-ray flux kind of minimal. We have a stealthy coronal mass ejection that is headed in Earth's direction. We'll tell you all about it, and lots more today here at the Smash News Network, least busted name in news. Let's zoom in a little bit closer, as you may have come to expect the channel to do. These are 24-hour videos from Solar Dynamics Observatory, and we've got a number of large active regions that have risen in the east, which would be your screen left. And of course, that's called the east of the sun because that's where sunspots rise. They set over here on my side in the west. So, the space weather rises in the east and sets in the west. This way, you can tell which part of the sun you're looking at any point in the world, as it may appear in an odd orientation when you're viewing it from the ground level, depending on your location, time of day, and so forth. Here we'll add 304 angstroms to show a little bit of additional definition there for filaments and a little bit of the chromosphere, filling in some of the blanks left by the 171 angstroms. And by the way, if you enjoy the content, take a moment to press the like button. If you're new to the channel, press subscribe. Otherwise, you won't see the world's most comprehensive daily space weather content delivered directly to your YouTube subscription feed. So please do also visit the links below the video once you're done leaving a comment and so forth. Press share. And we are hopeful that your posts are able to be seen on social media. Bravo. Just bravo. And speaking of social media, here's a quote from Kate Chopin. Perhaps it is better to wake up after all, even to suffer, rather than to remain a dupe to illusions all one's life. Yes, learning, it has a tendency to cause some brain pain. When you feel that brain pain, that's a good thing. It indicates new neural connections are forming. After all, these things are not typically comfortable. However, knowledge is comforting once you have some. So yeah, it's of course easier to fool people than to convince them they've been fooled. So certainly it's better to wake up than to remain a dupe to illusions all one's life. Moving on to some space weather stats. The radio flux, now at 169 solar flux units. And we have seen an uptick in sunspot number, which we'll get to here momentarily. There's the radio flux depicted over the past year by the black line from solem.info. And let's see. There is a little bit of geomagnetic storm forecast there on the way. Looks like a geomagnetic unrest there from late in the day on July 11th. So Thursday, July 11th, late in the day. We're also expecting some more stuff, which we'll cover here. Not exactly sure what NOAA's forecasting there. That looks like a weak coronal hole high-speed stream, which does seem like pretty appropriate timing there. As far as ESA's forecast, it is pretty much on the same page there. Both agencies expecting a weak coronal hole high-speed stream, yet a second one. Not the one we covered yesterday, but one in 2 days. Next, we'll look at Earth's geospace. Our geospace magnetosphere movie depicts magnetohydrodynamic pressure out to about 12 Earth diameters. And again, we have geomagnetically calm conditions at the moment. No significant space weather is buffeting the system. So that's what's going on magnetically in space. Here's what's going on magnetically at the ground level. And that depicts geospace delta B, so changes into Earth's B field. The B field being the field that goes through the magnet. It's kind of like a net of the overlap of the south and north polar fields, you could say. The B field, the field that goes through the magnet, changes to it in magnetic flux density. Again, things are mild. KP1 is the average of global geomagnetism, KP1. Next, looking at some solar wind data here. It's low and slow, diffuse and slow. Under 400 kilometers per second there at ACE, only 370 kilometers per second, and under 4 protons per cubic centimeter for the density. At Discover, a little denser, but similarly slow. So still under 400 kilometers a second there at only 5 protons per cubic centimeter. So pretty average density and a quite slow velocity. A little bit slower than what you'd normally expect. Next, we've got some maneuvering taking place there by the GOES 18. And the reason those arc jet moments are shown is because when a spacecraft turns on its thrusters to maneuver, plasma gets created, which can affect the magnetometer readings. So those areas are shown in yellow. Yeah, the GOES 18 maintaining its geosynchronous near equatorial orbit there, represented by the blue line. And it looks like it is still in the process of maneuvering. Next, the heliosphere magnetism. Let's see if we've snapped into that North Pole-oriented magnetic sector yet. And it looks like Earth has just done that in the past maybe half an hour or so. If you look at the latest image, Earth has no potential field surface source line then, an indication that the current sheet has likely already been crossed. So Earth likely in a North Pole magnetic sector there, depicted by green, as you can see in our Gong 2 National Solar Observatory data. So here is our line of sight field plot. Which brings us to coronal holes. That's the past 4 days. There are coronal holes. Some more North Pole-oriented ones rotating in here. And like we say regularly on the channel, you could expect to see plenty of coronal holes in the coming 6 to 10 months, as throughout the first half of solar cycle 25, we've seen quite a shortage of coronal holes. So, again, expect to see plenty in the coming days, in the coming months. So let's move to coronal holes from SDO. There you have it, 211 angstroms. And in about 4 days, we can expect to see another coronal hole high-density wave show up from that significant North Pole, northern hemisphere coronal hole. So it is actually of North Pole orientation. So that might cause a significant solar wind. We may even see a little bit of mild geomagnetic storming from that. Fingers crossed for all of you aurora chasers who hope to see that. Next, moving on to sunspots, and we have had a big uptick in sunspot number here in the past 24 hours. Sunspot number now about 142. That data from Royal University of Belgium. It's a royal university. So, we have a very high likelihood of X-class solar flares from sunspot 3738, as you can see there. It's a little over 50% chance, according to the magnetic shear. So there you can see that. We're going to show you some fantastic close-ups of this next. There's the equatorial zoom. And we're going to zoom way in, as we were able to get multiple awesome sunspot groups in there. So we are having some umbral growth there, kind of toward the center east portion of sunspot 3738, which is the one below the Earth scale there. That is going to be our most likely place for a large solar flare. Again, like we just showed you, could even see an X-class solar flare event from that now growing sunspot group. As far as the magnetic complexity, we'll look at that next. So we're seeing the North Pole umbrae grow there toward the end of the video. Really not a big change in the magnetic shear. So that's a 24-hour video at 30 frames per second. The SDO magnetogram. As far as energetic particles and flares, we ain't got no energetic particles, and flaring has been mild. So only C-class intensifications here over the past 24 hours. Here are the past 24 hours from the GOES, not the GOES, that's the SDO once again, the 94 angstroms wavelength. So yeah, don't be surprised to see an M or even an X-class flare. There are a lot of plasma filaments surrounding that sunspot as well, which we will show you here after we cover coronal mass ejections. But first, a little forecast. A little forecast for the little solar system. And I know it might seem big from your perspective, and we don't make the videos to make you feel small. However, the solar system is kind of small from even an interstellar sort of perspective. Certainly at a galactic perspective or an intergalactic perspective, the solar system is kind of small. Anyway, here's your forecast. That's where things will be in a week on the 17th. 16th, rather. July 16th. And here is our star chart. That's just what's going on overhead at Lehigh Valley, Pennsylvania. If you want to make your own, put in your location at skyandtelescope.org. And you too can do just that. Astronomy photo of the day is noctilucent clouds. Now, if that looks a little bit like a rocket plume to you, it is. It's also giving you insight into the wind patterns and location of the sun with respect to those noctilucent clouds located in the mesosphere. And it's a known thing that rocket plumes create mesospheric clouds. And so there you have them. It's not very mysterious at all. And apod.nasa.gov is where you can check it out yourself if you're into noctilucent clouds. It's not really space weather because the mesosphere is primarily the neutral atmosphere. It's not like the layer above it, the ionosphere. But in any case, let's move on to CMEs. So we have a stealthy coronal mass ejection. You're going to see one toward the end of the video come out of the southeast, which would be your lower left. And that is likely to have an earthly directed component. So it might not come out very well here. You're going to see one. Now, there, you can kind of see it coming out of the southeast. That came quite out of the center of the solar disk. So that very likely to have earthly directed components. You can expect that to arrive sometime later in the day on the 12th. So late in the day on Friday. Expecting a bit of a CME impact. Not likely to cause major geomagnetic storms. I wouldn't expect it to be above KP 6.33. It depends on the magnetic fields especially. And of course we'll cover it on Friday's Daily Space Weather Show. Now, of course, we've got some even more spectacular imagery of that for you. So here is our custom coronagraph. And once again, we've inadvertently captured a comet. You can see it kind of coming from right over in this area right here. Right there it is as it makes its way closer in there. It doesn't look like it's disintegrated yet by the end of the video. And again, you can see that second coronal mass ejection there popping off toward the end of the video. It's about, I want to say about 1600 Universal Time. Let's move in a little bit closer. So that CME, it came out of this area right here, kind of just south of sunspot 3738, right around here. It's a bit of a stealthy coronal mass ejection. And of course, people are getting better and better at seeing these things. So that's always a good thing. And there you can see a little bit of limb darkening there. We've included the 193 angstrom 60-minute running difference to help add a little contrast for you there. So some filaments have remained intact too. We've named one of those the smash staff filament. And of course, follow us on X. Follow the hashtag #NameThatFilament. You can see all about named filaments of the past. And speaking of filaments, here they are from Cerro Tololo, Chile. So that one that's kind of southwest of sunspot 3738, that's the smash staff filament. The ones to its east and south, they're not named yet. So thinking about naming those, we've got some ideas. Again, follow us over on Twitter, x.com/smashomash. Another place where you can share the content, and if you're an influencer, definitely press the share button. Thanks to everybody who has. We encourage more and more people to get involved in space weather because it's complex and nuanced, and we need more people covering it. So, cheers. We encourage you to start a channel. We'll consider you a friend, not a competitor. All right, so there's the grayscale imagery. And before we go to bonus features, the past couple of hours featured at least a huge prominence. Whether it ejected or not, I suspect some of it has ejected. Some of it looks like it has splashed back down, though, up there in the northeastern limb there, kind of behind the limb. A huge and spectacular prominence going on as we make the video. The Go 16 depicts the past 2.5 hours or so. And here come bonus features. We'll blast through these. Charging hazards are non-existent. The GOES electron flux here remains at kind of low levels. That's the past 3 days. Forecast model depicting remaining at low levels. No argument there. We'll show the layer where it's measured. The F layer. And of course, this isn't showing the particle flux density. This is showing megahertz, the vibrational frequency in millions of vibrations per second. And the ionosphere is looking very normal, except for the South Atlantic anomaly having moved to the coast. But besides that, and no surprise as there's no new space weather coming in, that's what's going on in the ionosphere. Here's the anomalygram, anomaly in megahertz from a 30-day median. It makes it really obvious where the South Atlantic anomaly has moved to, around the coast of South America, right at the 45-degree west longitude line, depicted by that negative 45 down at the bottom of the map. So, likely a change in the magnetosphere causing that. We'll also show total electron content and maximum usable radio frequency on our WAM, the whole atmosphere model. Again, things looking pretty normal in the ionosphere for today. Here come the latest high-res images. And first we'll take a little trip around here. Again, 3 new sunspot groups have risen. If you followed us on X, you might have already known about that. So there's 1, there is 2, and that might even be 2 more. That might even be 3 more sunspot regions there. But at least 3 new ones have risen. And let's take a close-up of sunspot 3738, since it is such a high likelihood of producing large solar flares. So we do see some deltas there, mainly in the trailing portion of it. I'm not sure if it's a 50-50 chance. Well, there are some deltas there sort of in the middle leading portion as well. So, yeah, fingers crossed for some more activity from that. There's the full disk. And we'll close out today's daily space weather content with the close-up of 193 angstroms 60-minute running difference along with 304 angstroms. That's ionized iron and helium. And once again, there's the house favorite, 171 angstroms. Anyway, thanks for tuning in to the Daily Space Weather Show. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. Headed back to the bunker. And in the meantime, may that solar wind be at your back. Whoa!